Hello, welcome back. In this video, we are going to learn about address in TCP IP. So let's look at the agenda. TCP IP addressing techniques would be discussed in this video. So TCP IP addressing techniques will be learned for two types of addressing. One is called IPv4 and the other one is called IPv6. Let us understand IPv4. IPv4 has 32 bits. Each byte is 8-bit long. So there are in total 8 into 4, 32. That means there will be 4 bytes of data. Let us understand the different fields. There are 5 classes of IP addresses. Class A, Class B, Class C, Class D and Class E. The leading bit of Class A is always 0. The leading bit of Class B is 10. That of C is 110. That of D is 1110. And that of E is 1111. Number of net ID bytes is 1. And number of host ID bytes is 3 here. So in total we have 4 bytes. So out of the 4 bytes, 3 bytes are used for host ID and 1 byte is used for net ID. For Class B, it is 2 and 2. That means 2 are used for net ID and 2 are used for host ID. For Class C, 3 bytes are used for net ID and 1 byte is used for host ID. Class D is basically used for multicasting. And Class E is reserved for future use. Let us understand the number of networks that is possible for Class A. You see here, for the net ID part, there is only 1 byte. So that means 8 bits. Out of the 8 bits, 1 is the leading bit. So we are leaving this. So we are left with 7 bits. So number of networks will be 2 to the power 7 minus 2. Why minus 2? Because there are 2 special addresses which are not used. And the range is 0.0.0.0 to 127.255.255.255. This is the range of Class A address. For Class B address, we can see that for the net ID part, it is 2 bytes. So 2 bytes means 2 into 8. So 16 bytes, 16 bits. Out of the 16 bits, 2 bits are used as leading bit. So if you leave that, we are left with 14 bits. So it will be 2 to the power 14 number of networks are possible for Class B. And the range is 128.0.0.0 to 191.255.255.255. Coming to Class C, we can see that there are 3 network bytes and 3 means 3 into 8, so 24. Out of 24, 3 bits are already in use. So we are left with 21 bits. So number of networks will be 2 to the power 21. And the range is 192.0.0.0 to 223.255.255.255. For multicasting in Class D, we can see that we cannot define the network here. For E also we cannot define the network, but we can define the range. It is from 224.0.0.0 to 239.255.255.255. For Class E, which is reserved for future use, the range is 240.0.0.0 to 255.255.255.255. 192.255. Now, class E and class D, they are used for future use and multicasting, and rest of the classes, like from class A to class B, they are used for normal usage. Let us now turn our attention to IPv6. Now, IPv6 has 128 bits in contrast to 32 bits of IP version 4. They are represented in hexadecimal numbers. Each hexadecimal number is 4 bits long. So we can say in total there are 32 hex numbers. So these are divided into 8 groups. And they are separated by colon. So let us see an example. This is an example of IPv6 address. You can see they are grouped like this and separated by colons. So we can have 2001, 0DB8, 85A3, 0000, 0000, 8A2E, 0370 and 7334. In total, there are 128 bits or 32 hexadecimal numbers. So this is the IPv6 addressing. In IPv6 addressing, we can use unicasting, which is one-to-one communication. We can use anycasting. Anycasting means in a group to any one of the device, the sender will send the data. That means if the sender is here, it can send the data to any one of the groups. Suppose this is a group 1 and having, let's say, 4 devices, the sender can send it to any one of these devices. Let's say it sends to this particular device. And it is also used for multicasting. In multicasting, the sender can send the data to all the group members. So to summarize, in this lesson, we have learned about the IP addressing techniques. We have learned about IPv4 addressing and IPv6 addressing. Thank you.